Okay, so before we get started, let's review where we were from last time. So, in the last section, we saw that f prime of a could be interpreted several ways. One, it is the derivative, or something called the derivative, of f at x equals a. Two, it is the instantaneous velocity or just velocity at x equals a, and this means that this is true if f is displacement. Okay. 3. It is also the slope of the tangent line. Tangent line 2f at x equals a. Okay, and so just more generally speaking, it is the instantaneous rate of change of f at a. Okay, so we saw that if f prime of a is greater than 0, right? That means that f is increasing at a, and if f prime of a is less than 0, f is decreasing at x equals a. So this is tied into the slope, right? And finally, wanted to mention the equation of the tangent line, just to put it all in one spot here. So the equation of the tangent line is going to be y minus f of a equals f prime of a times x minus a. And the way to remember that, right, is the point that the line goes through is a f of a, and the slope that the line goes through is f prime of a. Okay, so this is just point slope form. Good. All right, so in this new section, we're not really doing anything, we're not making any big changes except philosophically. So next, in 2.8, we look at f prime of x rather than f prime of a. So this was a number, right? And it had lots of interpretations that we just talked about. This is a function that tells us how to compute the f of a, right? So instead of computing f prime of a at each value of a, f prime of x will be a formula for computing, for example, the slope of the tangent line, or a formula for computing the instantaneous rate of change of the function. Okay, and so let's go ahead and just start in with our definition, and we'll just go from there and try some examples. So definition: the derivative function for f of x is just exactly the same thing that you've just seen. The limit as h goes to 0 of our difference quotient. Okay, that's our slope, f of x plus h minus f of x divided by h. Good. We're going to always use this formula, by the way. I should tell you that there are other there is another formula in the book, and sometimes that's useful for the algebra, but we're going to stick primarily to this definition. Okay, so let's see if we can compute the derivative function. Here's a few quick ones. One, f of x equals mx plus b. So if f of x is a line, then what is f prime of x? Well, you could go ahead and go through the computation, but f prime of x is the slope of the tangent line, and the slope of the tangent line is the slope of the line in this case, so the derivative is just going to be the slope. And so notice that is independent of x, right? Because a line's slope will be independent of x. Good. 2. How about for this one we're actually going to do a computation. So let's try limit as h goes to 0. Oops, I guess I better give you the function first, huh? F of x equals x squared. Okay, so then we'll take the limit as h goes to 0 of f of x plus h minus f of x divided by h. Okay, so that's equal to the limit as h goes to 0 of, now we plug in our x plus h to the function, and then we have x squared for f of x divided by h. And now we just continue on our computation. So go ahead and expand x plus h squared. Remember to FOIL this out. So that's x plus h times x plus h, right? So that's going to be x squared plus 2xh plus h squared minus x squared divided by h. Good. And now we're ready for our simplification. The x squareds cancel. We have a common h term that we can factor out, and that will be nice because we'll be able to cancel it. Good. And so then the last thing to do is to actually take the limit by substituting h equals 0 in, and we get 2x. Good. Now just as a reminder again, you can't plug h equals 0 into the formula right at the beginning, right? Because if you do, you would just have 0 divided by 0. Okay. Second note, f prime at a particular point A is usually easier to compute because you'll be putting in a number, right, instead of a generic x. So just as an example, let's take a look at the algebra in computing f prime of 1 if f of x equals 1 over x. Okay, then so this is from our previous section, right? So we would take the limit as h goes to 0 of f of 1 plus h, minus f of 1 divided by h. And so that would be the limit as h goes to 0 of 1 over 1 plus h minus 1, right, divided by h. And now to simplify the numerator, you have two fractions here, right? And so combine those fractions into 1 so that we would multiply this by 1 plus h over 1 plus h. So you would have 1 minus 1 plus h in the numerator divided by 1 plus h divided by h. Good. And what is that going to be? I guess we still have a little bit of algebra to do, huh? Minus h. I'm going to go ahead and take this and put it out in front as a 1 over h. And then I've got the 1 plus h here. And then I've got minus h in the top. Good. And now I can cancel out my h's. And if I plug in h equals 0, I get negative 1. Good. Now I just wanted to compare that briefly. How would you compute f prime of x if f of x equals 1 over x? Okay, we're going to compare the two computations here. That would be the limit as h goes to 0 of f of x plus h, so that's going to be 1 over x plus h minus 1 over x divided by h. Okay. so that's going to be the limit as h goes to 0. Now we need to multiply this one by x over x, this one by x plus h over x plus h to get a common denominator. So we would have x minus x plus h divided by x times x plus h. And then I'm going to take this and bring it up as a 1 over h in the front, just to make it a little bit easier to deal with. Good. And now you can kind of see that there's a similar computation going on, but this is a little bit more difficult to do. You're going to have your h's that cancel, and then you're going to have x times x plus h down here. And so now if we cancel our h's, plug in h equals 0 to take the limit, we end up with minus 1 over x squared. Good. And so which one is harder? I guess they're similar, but sometimes I think students find it easier to, if you're computing f prime at a particular number, go ahead and use that version of the formula, plug in that number right off the bat. Because notice that you could also compute the general formula for f prime of x, and now, for example, f prime of 1 is equal to minus 1 over 1 squared, right? F prime of 2 would be minus 1 over 2 squared. F prime of negative 1, you could do that one too, minus 1 over minus 1 squared, etc. Okay, good. I'll stop here and we'll continue in the next video.